So today we will start with the first MATLAB examples where I will teach how to determine the percent overshoot, the rise time, the peak time. All this will be what we call it the step response characteristics by using the MATLAB. So at the same time, I also will show term from transfer function, a system, and then to plot the step response. So I usually will start to give some comment. Means let me understand what this exercise about. So this is to determine the step response information from a model. Okay, so we name it the example 1. Okay, so as we can see from the first examples, we were given the model where we can declare them in the MATLAB. What we call this declare the numerator first, then the numerator, because it's already in polynomial, so it's very easy. Then I just type the number of it, and then after that I try to call this as the gx, and then transfer function is the common transfer function. I think I don't need to introduce again. This is the transfer function command where you can use it to determine the transfer function of a system. So numerator x and the numerator x. Okay, so well, because I write it using the script, so once before I run the script, there is no answer on the command window. So let's finish first. So what does I have the gx with me, and then we call it to plot step response, because I would like to let you to see the step response before you determine or before you understand the transient response and steady state response and so on. Okay, so I usually do teach the student you can decide how long your response you want to execute for. So let's say we start from the 0 second, and we will collect the data every 0.05 second for 5 seconds long. Okay, then so I try to collect the output of the step response by using this step function. So this is the second function that we learned today. So step and step of our transfer function with the time t, which we have declared in the early part. Then okay, once I have the step response, I plot it. Then of course this is just declared, so next I need to plot it. Plot t ys. Okay, as let's say I want to I want to make it with the thicker line, and I also want the grid with the grid on my figure, so I can use this way. So many things else you can do later on. Let's say like I want a title for my figure, so you can type the title just like okay, step response of GS. Okay, So what is done, then okay, so definitely you can use the x label. Our x-axis is time, yeah, so just type time second, and y label. So since this is we don't know what system is it, so then we just declare here is the output. Okay, so well, once I have done this, then next is we will determine the response information. Okay, so in this we will try to use the step info command. Okay, so once we use the step info command, definitely of we must declare that's our system where we want to get the step info, and there are many things else such as examples like this. In this exercise, he said we can set the setting time, or we can set the rise time threshold. So let's say that we want is the rise time threshold limit. Okay, rise time limits. There are many things else. Okay, you can get more information from the help file actually. So okay, once I have this, then I should know, because from the question it mentions 100%, so it's just 0 to 1. Okay, so it's considered done to answer the question. So let's run what happened. So before you full run the execute this whole file, you need to save it. So let's say we say this is example 1, example chapter 3 1. Okay, because I'm using is the okay, so okay, I have the mistake here. It can't run because he said unrecognized function or variable. Then we check again gs, because I declare the gx here, so I must use gx here. Okay, so let's run again. Run. Alright, so you can see that unrecognized function again, so that means we need to change the gx here, and of course, yeah, until the figure there's no problem, but we can't get the information here because I made a mistake. Is the gx the system name, and one more thing is we found from our command window it show up a lot of data. It might be quite a little bit messy. It's too many data, so I don't want this to appear here. Okay, probably I can just refer from the workspace, so I may use a semicolon for this. Sorry. So okay, then let's run again. Okay, because this one is at run for the, yeah, this is my step response, and from what I can see here, I have the gx which I declare, because I don't use the semicolon, so the answer will be appeared on my command window. Then after that, we compare this transfer function. Yeah, it's same as our examples, the questions. Then next is draw the figure. What I said is from 0 to 5 seconds. Yes, definitely is. And there's the step response, the title, step response, the X label, time, and the output, this is the output. So you can double check is the system collect when they run every 0.05 seconds they collect the data or not. You may come to T. Okay, double click your workspace. Okay, tick tock, tick tock. Okay, where it will go. It might take time because I'm using the MATLAB online, so I bet you won't have the same problem as mine. Okay, is it opening? Okay, it's here, still loading. Okay, so you can check from the T, which is same as what we have set here, that from 0, so every scale of 0.05 second what we set, okay, it will run it, the T set is this. So we have total of 100 data. So then because we run our ys using the step function according to T, so definitely our ys also will have 100 data. Okay, so back to our figure. Okay, when we observe this response, then check with the information that we have. So rise time from 10% to 90%, 1.1782. 1.1782. So the overshoot 4 point something, and the peak time is 1.56, happened at 1.5. It's around here. Okay, so well, there's we have done the examples where you can understand the transient response and from the response that you have plotted from a model. Okay, that's it. Thank you.